In my previous videos I have shown my CPU and computer design simulated using Logisim, VHDL via GHDL, Verilog via Icarus Verilog, and my own text-based simulator. Now I'll show my Graphical User Interface, or GUI, version of my simulator. I'll go back to Logisim specific stuff in my next video, which will be quite a surprise and quite a paradigm shift. This simulator will be very useful for that shift because, for one thing, it runs much faster than Logisim, so be sure to check out my next video when I create and upload it. This simulator runs faster because it doesn't have to simulate the electronics of the CPU and computer. One problem with only having the Logisim, VHDL, and Verilog simulators is that they all depend on the designed wiring and electronics. Let's say you write an assembly language program for the CPU design and it doesn't work. Is it because the program has bugs? Or the hardware design has bugs? It might be hard to track down, especially since the wiring might all be correct, but quirks of gate delays and timings might be screwing it up. Especially true if you actually put it in an FPGA. But my simulator does specifically what each instruction is supposed to do as specified in my instruction set list, regardless of the electronic implementation. My simulator has a few different ways of timing the execution. By default, it uses a Windows timer event to trigger an instruction execution. Windows timer events are in milliseconds, which means at most they will occur 1,000 times a second, or 1 kHz. This really isn't fast enough, so I programmed the option to not use the timer event. In this situation, an instruction is executed during each iteration of the Windows main message loop. The problem with this method is that Windows typically doesn't have enough time to update the various dialog and window elements. For example, the PC register value display gets updated, but the Y register value display doesn't. This method still isn't fast enough, so I put in a fast mode. In fast mode, the program doesn't even try to update the less necessary dialog and window elements. It's amazing how much faster it runs in this mode. Of course you won't know the value of the registers, but it's an acceptable trade-off. The MIDI device is implemented. The instrument and MIDI channel can also be selected. There's also different ways to load a program. The file can be specified on the command line as shown before. The load button can also be used. And if the show program option was desired but forgotten, selecting reload program from the menu is a good idea. There's a few more ways I'll cover later. If the show program option is selected, the simulator disassembles the program while loading. It's not reading the source code. The highlight instruction option highlights the currently running instruction. The show program option is off by default since very large programs can take a while to put in the listing window. The speed value changes the delay used. You might want to slow down the execution so you can better see what's happening. Highlighting slows down the simulator, so it should only be used when necessary. The simulator can be resized. During resizing, the various sections resize and shift accordingly. Some sections only shift or resize past a certain point. By default, the text in the TTY screen word wraps to fit within the TTY screen area. If word wrap is turned off, the scroll bars can be used to see all the output. There's various other things that can be done from the menu. Toggling the TTY Windows frame is an example. Choosing to use a FIC frame allows the TTY window to be resized and moved separately. In my opinion, using FIC frame for this window in Windows Vista and above looks ugly, so this option is off by default under those versions. Under Windows XP, FIC frames look better, so the default is on for XP. Double-clicking the left mouse button in the non-dialog box areas toggles the color combinations used for the program listing. This feature also can be selected from the menu. The real-time clock value can also be displayed. A program that requests the time is required for this value to be updated. It can be as simple as this. The 24-hour clock format can be selected as well. The No Lag LED Matrix Design option selects the no lag version of my design. Clearly, in fast mode, it runs too fast. There's also the instruction TTY component from my design. This does a similar function as the program listing window, but it doesn't load the whole program into the window. It disassembles on the fly. The value indicators have tooltips to give a better description of the function. For particularly hard to diagnose bugs in a program, the single step button can be useful, stepping one instruction each time it's pressed. By the way, a breakpoint instruction can also be put in the program to show the value of the desired register or memory location. This is another way to diagnose bugs. The Y and A register LED displays can also be turned on and off. And TTY Clear toggles whether a program can clear the TTY screen. If the option is off, a program cannot clear the screen. This is useful if the text displays and clears too quickly to see. A clear completely removes the text from the window. I'll take a brief intermission to explain the background image. I made this background image so you don't have to look at a boring desktop during this video. It basically shows the history of my CPU design. My original drawn-on-paper many years ago design is on the bottom. My first Logisim implementation of it is on the top. My first Logisim computer design on the right. My most recent CPU design in the back. And on the left, a sample assembly program for my CPU and computer. Back to the simulator demonstration. Now I'll show other ways to load a program or start the simulator. I don't use a file extension for my CPU programs, so for the sake of this feature, I made a .cpu extension, and told Windows to use my simulator to load CPU files. So now, double-clicking on the CPU program file will run the simulator, if it isn't running already, and load the program. Windows Vista and above remove the capability to easily change how specifically a file of a given extension is loaded via the Tools, Folder Options, File Types, menu path. So I had to use regedit to change how a CPU file is opened, adding various command line options. Another way to load a CPU program is to drag and drop it into the simulator window. If the program is dropped in the program listing window, the simulator disassembles it as well. Forgot to mention, there's also the CPU status LED. The other round LED is the strobe indicator. And here's the command line options. The maintain only one instance option is used to only start up one instance of the simulator when double-clicking the CPU programs in Windows Explorer. If the simulator is already running, the new CPU program will be run on the existing simulator rather than starting up another simulator. And here's an example command line startup. Well, I guess that's it. Back to Logisim next time.